Welcome to Mathland. For our final major proof, we tackle the Tan-Chord Theorem. We have a tangent line touching the circle at A and a chord AB. The theorem states that the angle between the tangent and the chord, which we will call A1, is exactly equal to the angle in the alternate segment, angle C. To prove this, we construct a diameter. We draw a line straight from A through the center O up to point D on the circumference. Then we join D to B to form a triangle. Our first geometric reason is that a tangent is perfectly perpendicular to a radius or diameter. Therefore, the tangent angle A1 plus the inner angle A2 must equal 90 degrees. To make the algebra easy, let us say that A1 is equal to x. That means A2 is equal to 90 minus x. Next, look at the triangle we built. Because AD is a diameter, the angle at B is an angle in a semicircle, which is exactly 90 degrees. Using the sum of angles in a triangle, angle D must be 180 minus 90 minus 90 minus x, leaving us with exactly x. For the grand finale, look at angle C and angle D. Because they both subtend the exact same chord AB, they are angles in the same segment, creating our familiar bow tie shape. Therefore, angle C must also equal x, proving perfectly that angle C is equal to the tangent chord angle A1.